So today we are going to discuss about the topic magnetic materials. I am Yan Ratna, Assistant Professor, Department of Physics, APC Mahalakshmi College for Women, Tuticorin. So today we discuss here what are the classifications of the magnetic materials, that are types of magnetic materials. The important five magnetic materials are diamagnetic materials, paramagnetic materials, ferromagnetic materials, antiferromagnetic materials. Diamagnetic material. So when some substance are placed in a magnetic field, they are weakly magnetized in the direction which is opposite to the direction of a magnetic field. These type of materials is known as diamagnetic material. Examples of dia is bismuth, gold, silver, water, quartz, and etc. The next one, what are the properties of diamagnetic material? It has a permanent dipoles are absent here, and the effect is very small. When it is placed in a magnetic field, all the magnetic lines of forces are repelled, and they have the negative susceptibility value, and the value of chi is independent upon the magnetic field applied, and it is also independent upon the temperature, and the relative permeability is less than 1. And paramagnetic materials, it possesses a permanent magnet dipoles. When it is placed in a magnetic field, it attracts the magnetic lines of forces. But in the absence of an external magnetic field, all the dipoles are randomly oriented and the net magnetization is zero. When a small amount of magnetic field is applied, there is a small amount of resultant magnetic moment. Sometimes even in the absence of magnetic field also, there is a small amount of magnetic moment is present. And some of the properties, if we apply the magnetic field, there is some induced magnetic moment along the field direction and the magnetic induction will increase. And here the chi value is negative and it is depends upon the temperature. And here it is independent upon the applied magnetic field strength. When the temperature is less than Curie temperature, it is converted into diamagnet, and some of the example chromium, oxide, nickel sulfide, etc. And ferromagnetic materials. So due to some exchange coupling between the adjacent atom, it exhibits strong magnetization even in the absence of external field and have a particular temperature, Curie temperature. When the temperature is less than theta C, the material is in the ferromagnet. When the temperature is greater than C, it is converted into the previous state, that is paramagnetic state. And some of the properties, they are strongly magnetic lines of forces are very strong and they exhibit a magnetization even in the absence of magnetic field, and it consists of a number of small spontaneously magnetized regions, that is called domains, and the spin alignments are parallel and in the same direction, and chi value is very large and positive and it depends upon the temperature, and examples iron, cobalt, and nickel. Antiferromagnetic material. Any material having the magnetic interaction between any two dipoles, they align themselves anti-parallel to each other. That is called what? Antiferro. And here the chi value is small and positive. The chi is increases when the temperature is increases and it reaches a maximum value. That particular temperature is known as Néel temperature. So after the Néel temperature, it goes to paramagnet, and below it goes to antiferromagnet. And some properties, here the dipoles are aligned anti-parallel with each other. As a result, the resultant dipole magnetization is zero and chi is small and positive and depends on the temperature. Thank you.